How does a car convert fuel into power to run? What steps have been taken? Today we will explain the principle of a car running in a video. There are many steps, and the content is relatively long. If you are also interested, it is recommended to click on a collection first. I am afraid you will not be able to read it all at once. When we get on the car and press the start button, the battery will power the start motor, and the start motor rotates to drive the engine crankshaft to rotate, so that the pistons in the engine start to move up and down. At the same time as the start motor works, the oil pump in the fuel tank will also start to extract fuel and pressurize the fuel into the fuel pipe. The fuel pipe reaches the fuel injection nozzle in the engine. The fuel injection nozzle is a pressure relief valve that can spray fuel into the engine in an atomized manner. When the atomized fuel enters the engine cylinder, there will also be air entering, and they will be mixed according to the air-fuel ratio of 14.71. The engine converts fuel into power in 4 strokes. The first stroke is aspirated, and the fuel and air are drawn in according to the air-fuel ratio of 14.711. The second stroke is compressed, and the fuel and air are compressed to the top area, forming a high-pressure mixture. The third stroke works the spark plug, ignites the mixer, and the mixer will deflagrate immediately. The thrust from the deflagration will push the piston down, and the fuel will be converted into mechanical kinetic energy at this time. The fourth stroke vents, expelling the burned mixture out of the cylinder. This cycle is very fast. At 3,000 RPM, a single cylinder of a 4-cylinder engine completes 25 4-stroke cycles per second. After the fuel is converted into power, the car rider can run. But the car also has to change gears, so the power must go through the gearbox before it is transmitted to the wheels. The function of the gearbox is to change the torque and speed of the car through the combination of gears of different sizes. There are several types of gearboxes on the market: CVT, dual clutch, AT, and manual. The principle of each gearbox is different, and I won't talk about it in detail today. In order to prevent the engine from leaving the West Lake when the vehicle is slowing down and stopping, each gearbox has a device to cut off the power. The CVT and AT gearboxes use a torque converter, and the dual clutch and manual gearboxes use a clutch. And the power is not just transferred to one wheel, but either to the 2 front wheels or to the 2 rear wheels, or simply to all 4 wheels at the same time. So there is also a drive shaft connecting the 2 wheels together, so that both wheels have power at the same time. The technical word for this drive shaft is the drive axle, which is the axle that drives both wheels at the same time. The power of the engine first passes through the gearbox, and then passes through the drive axle to the wheels. Because the engine is in front, the transmission box of the front drive car is directly connected to the drive axle. If it is a rear drive car, a drive shaft is used to pass through the body vertically and then transmitted to the drive axle of the rear wheels. Similarly, a 4-wheel drive vehicle adds a drive shaft to the rear drive vehicle to divert power to the front wheel drive axle. Don't worry, it's not over yet. When the car is turning, the outer wheel moves significantly more distance than the inner wheel, which means that the outer wheel turns faster than the inner wheel. If the speed is the same, the car will not be able to turn. So the drive axle is not a whole, but is connected to the left and right half axles through the differential. The function of the differential is to allow the 2 wheels to run at different speeds at the same time. Power is first transmitted to the differential and then diverted from the differential to the wheels. At this point, the process of power transfer